I mentioned zero carbon power, which is a huge topic. All these ideological changes that can't then went to the discussion and graduated in 85 as you would in level engineering, and he worked for comes out to 30 years, and I came out that it was a Calgary power thing, and they diversified. They went on with AEO, which is the electrical operator, managed the power in Alberta, and then he that time he has a knowledge of the electrical systems, here and the operation, which is where we're going to do these issues of wind power, solar, etc. I'm old enough to was big times of water, hydroelectricity system, and then nuclear. We had electric relays. And of course, that changed gas turbine, gas burning. That's all about falling into what supposedly is new energy. This is what Trevor's going to we're doing in Alberta from like a request Trevor the speech, and he would request the questions come at the end rather than during the speech. So, thank you very much. Thank you, Trevor.
Thank you very much for your introduction, Robert. And I guess I'd like to thank you guys for giving me the opportunity to talk about what's kind of a project myself, which is the Echo Zero carbon sort of like this talk. And I consider this a really critical issue, an important subject in Alberta, and full understanding the cost and cost of the option, I believe, is key to developing a strategic plan if Alberta is going to achieve the lowest possible net zero power system. In my opinion, Alberta is evidence in how futuristic life, and under the existing policy, rules and regulations drift towards a high cost of electricity. And I also strongly believe that Alberta is strategic and long take meeting that if we're going to shift to a path we can those possible costs net zero grid.
Just
sure.
Up a little bit. You to
No. Unless it's under something.
Well, maybe I can ask you to speak louder. Yeah. Thank you.
Yeah, you just try to. Now I've lost the meeting. Okay, there we go. Okay, is that B? Okay, where was I? So in preparing this talk, I'll talk about what I think are three key considerations for strategic planning for Alberta. The first one is, and given its advantages and limitations, were lowest cost, zero carbon generation technology choices. The thing is, given the fact that it has no significant amount to store solar, intermediate reserve cost at zero regime, that doesn't change. I'm going to get to that. And third, talk about, which I think is really important as well, is in a net zero regime, the new synergies and opportunities that could be created between Alberta and the BC system. So first, with respect to zero technology, where
terrible.
locations are different. In the case of where the load factors, in my opinion, you have an abundance of natural gas reserves, especially now the fracking that will change. And with fracking, the reserve types of gas are just mind-boggling, quite frankly. And you also have fleet reservoirs that are suitable for CO2. And both are located to where we could generate some advantage as far as CC carbon capture and storage. We do have reasonably high as far as wind goes, not absolutely the best, but it's at the top in North America. Solar production, even though they're building lots of solar, we low quality production that's due to emission. Bottom line is we get a lot of solar in July and August, and the time it's tapers off to almost nil for the long winters. The factor that needs to be considered is we have extensive skilled workforce, like engineering, large project management. We've got experience in the province with doing large projects, steel fabrication, complex operates. And so, given that, zero carbon generation choice for Alberta, one of our Q2 sequestration. And I put on here is basically curve for, right, starting first with combined cycle. That's basically current is that, nothing changes. This is how much it costs to produce power in Alberta by 2035. All of these include assumed improvements in technology to 2035. The next one is nuclear. This is the small modular reactor, which the Canadian government is the small modular reactor initiative. Next to that is CC stands for combined cycle. So this is a combined cycle plant, and then with it on of a CCS, a carbon cap storage plant. So the two separately. Yeah. Oh. The last one put up here. This is intermittent resources, this is basically wind primarily, and this is confirmed by combined cycle with CO2 sequestration. Because one of the issues that we're going to face, and I'm going to talk about this a bit more when I get to wind, is once you move to net zero, the cost, the base cost, the cost of the plants goes up dramatically, which means the cost of firming wind and solar rises dramatically. And this is something we really need to consider right now, right away. In my view, my mouse. This is the path we're currently on. Nothing changes with regards to the way the industry is structured. If the government doesn't take any action, we're going to by default end up on a very high cost path, which basically what we would be looking at is electricity costs over 3 times what it currently costs to make power today. So given that slide, nuclear is clearly the lowest cost technology. Nuclear represents a perhaps 30% increase over what it would cost if we continue to burn natural gas without the sequestration. It's a 3 times lower cost on the path that we're currently on, which is integrating a bunch of resources with CO2 sequestering plants. So to me, the big question is, a lot of people are skeptical. Can we do it? We have no nuclear industry. So barriers to Alberta nuclear. I think one of the biggest barriers to Alberta becoming a nuclear-fied province is actually the federal government's net zero by 2035. 2035 is just such a demanding short period of time. The Stream 1 small modular reactor program is the first reactor is 2032 in Saskatchewan. Only 3 years before the 2035 deadline. Stream 2 is 29 to 2035. That's just to get the first of kind plant built up and running in that time frame, which leaves almost no time to actually construct and implement the role of a fleet of nuclear reactors. The other barrier I can see is a philosophical political opposition to crown corporations in Alberta. And the reason I say that the barrier is because if we're going to make a wholesale switch to nuclear, in my opinion, it's got to be done through a crown corporation. You've got to have a single agency operating a fleet of common nuclear plants, managing the fuel cycle, managing the fuel, managing disposal if we end up, or however the fuel is managed, whether we take it back to Ontario or what have you, and also the risk. Simply first of kind risk with nuclear plants. MIT recently did an analysis of this, and the first of kind plants typically come in 8 to 9 times the cost of your nth of kind plant. So even to do that 100 megawatt first of kind plant, you're talking a $6 billion prototype, basically, for a plant that ultimately would start selling for $600 million per plant in the future. So for all those reasons, I think to get it done fast and to get it done effectively and simply dealing with the nuclear issues, it's going to have to be a crown corporation. And I'm not sure that this government has the palate to create crown corporations. So the other one I talked about is it's going to require a large upfront investment, and I think it's going to require Alberta taking a much bigger role in the SMR program. The SMR action plan today is really being driven by Ontario and New Brunswick, and the plan, even though it's a federal plan, it's really catering towards the needs of Ontario and the needs of New Brunswick. The other barrier that I can see is opposition by the incumbent generators. Bringing in a whole series of nuclear reactors is going to push a bunch of people out because they're going to be high cost generation, and they're going to do whatever it takes to resist that. They want to get those high. They want the price in the market to be high, and they want to make money, and they don't want to be shutting their plants down early. So you're going to get a lot of resistance from the incumbents. And then the last one is a lack of political will for decisive action. Like to do something like this, you would have to really politically, they'd have to be decisive. And I think that's a barrier as well. Now, opportunities, like I said, sorry.
Can I just ask, can you just switch off your video? Because we seem to be struggling with one. That's it.
Okay.
Thank you very much.
Great. Insurance pause. So when I stop the video, does it stop the screen?
No, it was there before. Resume share maybe? Just about.
I can see.
One.
Okay.
Sorry.
I want your.
It was the next one.
Oh, resume share. Yeah. Okay. Okay. That's embarrassing for engineering to have such technical problems. And I'm probably going to go way over time because I'm talking too much. Opportunities for nuclear in Alberta. I think we could do this, quite frankly. We have a large pool of engineering, fabrication, and construction expertise, and the grid was designed and built for large central generation hubs. So the grid transmission system as it exists today would actually work very well with large centralized generation, basically replacing what was coal centralized generation. I think there's a strong public support for nuclear. People see it a way as reducing our CO2 outputs, and I don't think there's that much fear of it. And we have the money. If the government wanted to do it, you could put $3 or $4 billion, which is what I would think it would take to start a crown corporation with the objective of getting the sites and starting to really actively finance and participate in the small modular reactor program to accelerate it however much you can. And Albertans have shown historically a strong tolerance for risking the money and go up to the first of a kind. First of a kind is very expensive, but I think Albertans, they're not going to vote with the government. I mean, we just threw $1.5 billion away rolling the dice that Trump would win, so we get a pipeline, right? And people don't really seem to have made much of a deal of that. And we have a culture of get it done and that we can do things through innovation. Now, going back to what I was talking before when looking at that table, wind and solar are clearly the highest cost technologies, which probably surprises people. They're thinking renewables is the answer to net zero. If we do a combined natural gas with sequestering with large amounts of renewables, that's 320% of today's comparable cost of generation production. And it's 2.5 times the cost of nuclear. So why is wind so costly in Alberta? We're supposed to have, we've got these great wind resources. Why is it so expensive? Well, the costs that go into the wind in Alberta is first of all, is the cost of the long transmission lines to the high production regions. You've got a high fixed cost of dispatchable generation, and with the net zero requirement, those fixed costs go up very high on those units, which then has to be should be, but isn't today, should be paid by the intermittent resource that unit is backing up. So that guy is sitting there with that asset to back up the wind. If I'm running megawatts hours into the market, I should be paying the proportional cost of his fixed cost to hold him whole. The other problem is fluctuations in rapid ramping up and down of intermittent resources. And I did some illustrations of this, but I don't know how time to get to it. But both the nuclear and the integrated combined cycle with carbon capture and storage, they don't ramp quickly. And in fact, the carbon capture and storage integrated plants are based on base load only. The assumption is they'll never run at part load. So that's a huge problem. If you're having, in the case of Alberta, you can ramp from 0 to 100% of the entire grid load if you're supplying with wind within a matter of 3 hours. So you have to ramp your entire thermal fleet from basically minimum load to maximum in 3 hours. And then the other problem with wind and solar is that because of the part load of your thermal units, your heat rates go up. So when the units are running at part load, especially gas turbines, you burn a lot more natural gas on a per megawatt basis. And the units that I'm most familiar with, like the aeroderivative units especially, these are the ones that can respond to the fluctuations in wind and gas. An aeroderivative unit, when it's running at 0, it's burning 50% of its gas. So when you're idling those units, you're almost burning more than half of the gas that would have burned if you're running the unit at full hour. So even when you're running the wind a lot, you don't get a lot of reduction on the variable costs either, because these units have to burn their gas anyway, and they have to keep their sequestering plants running anyway. So this is why the wind is very expensive. So what I did is one thing some people know, a lot of people don't, is how heavily subsidized wind and solar is in Alberta. And that was deliberate, and I was involved in that. So you can partially blame me, but the way the market is set up in Alberta is, first of all, transmission is free for the generator, and the generator is absolutely guaranteed he will never experience congestion. And going beyond that, the ISO has to build transmission in anticipation of congestion. And so what's happened, and has been happening for years, is the ISO ends up building 3 times as many lines as they need, because a wind farm might go over here, it might be over here, it might be over here, so we've got to build transmission in all 3 areas. The CBW development down into Southern Alberta is the worst example of that. I think it cost, between the 2 lines, and the station, all in, it was close to $1 billion. That system sat empty for 7 years. At the very end of it, nothing was connected to it. In fact, it cost us money because of the losses into the reactors that kept the voltage down on the lines. And even the piece between Medicine Hat and Calgary wasn't actually required until finally the first wind farm was added to the line. And so those are why, to date, our transmission costs have been very high for wind. When I did the future, the 2035 wind, I made an assumption, and maybe it's optimistic, that it would be least cost transmission that would be built. There would be some change so that only transmission would be built when a farm is there, rather than building transmission everywhere. And even then, the wind is very expensive. So if we add in the transmission costs, today, wind is still, with just the transmission costs, wind is still slightly cheaper than combined cycle. What's interesting is the solar becomes very expensive when you add in the transmission. And the reason for that is the very low utilization of solar. It has to have the line capacity to run the plant at maximum, but the vast majority of the time it's not using the line at all, because solar has such a low capacity factor. What's another interesting thing when you add in the transmission costs is, you see I've put land-based wind class 8. That's wind scattered throughout the province wherever there's transmission capacity, wind that you could connect up without having to build transmission lines. If we had done that from the get-go, we would have actually ended up with cheaper wind, even though the producer doesn't make as much money. Overall, the wind would have been cheaper. So unintended consequences, I would say, of the way it was subsidized. And then the last one I put on here is commercial PV. This is like the Chinook solar panels. And so once you put the transmission costs in there, building solar on top of large urban facilities like the shopping mall actually becomes cheaper than our current wind, simply because you don't have to put any transmission in. The next cost you have to add in, finally, is the firming cost. And the firming cost is there's different ways of looking at this, but basically firming costs is the amount that the wind generator has to pay in order to hold the thermal plant guy whole on his costs, because that guy's running at part load or low load, or just sitting there idle waiting for him to drop out and for him to pick up the load. So it's a way of transferring the cost to the wind generator. Economically, it's basically pure cost causation. Markets have very different ways of kind of transferring that cost. But once you add in the firming costs, you're basically left with today, and we don't have any. If we had built our wind on the transmission system, it would still be economical than combined cycle. But all of the others, and if you look at for example, the solar that's going in now, once you add in the transmission and the firming costs, it's dramatically more expensive, almost double the cost of combined cycle natural gas generation. So then I went out to 2035. So in 2035, what changes is the nature of the fleet changes. So we could have, and I've compared these costs to nuclear, but for the wind, what I did is I based the costs on firming it up with a combined cycle with a separate carbon capture and transportation and storage system, two separate systems. And primarily that's because that's the kind of plant that can ramp up and down. And you probably would mix that in with gas turbines fired with hydrogen to provide aeroderivatives, provide even more ramp capability. I think in the ISO's scenarios, they do kind of a mix of the two. I personally, the gas turbines fired with hydrogen are very expensive. So that's it. So this is, to me, this is probably the best case, is that you can get a sequestering plant that can ramp up and down rapidly. People are skeptical this might not even work. So again, if we load in the transmission costs, the renewables are still cheaper than this new nuclear plant. But then when you add in the firming costs, because of the high capital costs of these new plant designs, firming up the wind becomes extremely expensive. And so basically, if we continue with wind and solar, the wind and solar resources are going to cost more than double what nuclear would, roughly. In which case, which raises the question is, why would we want wind and solar on our grid? If we're going to go nuclear, you really don't even want the wind and solar. It's not economical, quite frankly. The one other thing I added on here, which I always hear this all the time from people, is, oh, that's okay. When the wind's not blowing, we'll store all that energy and we'll bring it back onto the grid when the wind's not blowing. So I put on the lowest cost storage choice in Alberta for wind, which is hydrogen energy storage systems, and it's more expensive than actually firming it up with gas. So I don't really, and this is with technical advances, so I don't really think storage is a solution at all. So the question I pose is there no future for Alberta wind and solar? The existing BC path, you can firm up a small amount, but it's maybe less than 700 megawatts of wind. The lowest cost generation technologies, your nuclear and your integrated sequestering plant, just cannot accommodate the variability of the intermittent resources. And then the high capital cost, which I was talking about before, future technologies means high cost of firming, which is what makes the wind and solar so expensive. And the storage options available to Alberta, and I had a piece on that, but that alone takes 20 minutes. I parked it, but the storage options available in Alberta are just not economical. They're just not viable. And the one thing I should say about storage, though, which now I'm going to get into a little bit, is when people look at storage, when you're looking at those megawatt hour costs, they're based on the capacity going out being equal to the capacity going in. To firm up wind, you have to have double the ingoing capacity that you have coming out because of the low capacity factor of wind and the losses within the storage system itself. I looked at wind, for example, with compressed air storage, which doesn't actually give you net zero, but it's the cheapest. And compressed, I should say the hydrogen, the HES system is probably a better example. But if you go to hydrogen storage, the round trip efficiency of the whole system is 30%. That means you lose 70% of what you go in. So if you firm up wind with storage, if your capacity factor is 41, your firm output is somewhere around 11%. You basically lose 75% of your wind in the total round trip process. So that combined with the high cost of the storage just makes it completely uneconomical. So the big question is, what are you going to do with the 15 billion plus that we already sank into transmission, wind, and solar? That's roughly what we're at right now, and it's getting higher. So this leads to my third topic, which is BC has the hydro, which is what you really need when you've got wind. So what are they up to in 2035? Now BC has, and typical BC, they've done a very good and thorough job on this. They have an integrated resource plan which is really a complete strategic plan with a 20-year horizon. And looking at that plan, what opportunities or questions that rise, at least in my mind, with regards to benefits that Alberta could potentially leverage off of what BC is planning to do. So I noted a few things. So first of all, BC's reserve capacity by 2035 is going to be 1,600 megawatts. What that means is when they don't have plants on forced outages, they can they can provide for capacity to BC out of their reserve. It's a little bit more risky for Alberta, but the capacity is there. Second thing is BC, and this has been known for a while, but they can expand their hydro capacity at a fairly low cost. For example, Revelstoke is all set up for, I think, 3 more units. So if you want more capacity at Revelstoke, you just have to add the penstock and the turbines and the generators and the rest of the infrastructure, but you don't have to add or modify the dam significantly. So that's not cheap, but it's low cost capacity relative to building a completely new plant. And then lastly, not lastly, but by 2035, in their BC, and this has always been the case, but BC is energy deficient, but not capacity deficient. And so they're forecasting by 2035, they're going to have a cumulative total of 11,000 gigawatt hours per year deficiency in their energy supply. That's roughly, I think that is in the order of 3,000 megawatts of wind output at 41% could meet that need. So they could take basically 3,000 megawatts of our wind and use all of that energy if we can get it to them. And then as far as capacity goes, BC currently has a surplus of 900, but they're forecasting that they'll be up to 1,645 megawatts of surplus by 2026. This is on top of the 1,600 megawatts of reserves that they hold, capacity reserves that they hold. But then this will decline through to 2030. And then the last thing I note about their plan is they've looked at this quite extensively, and they have plans in place that they really believe that their electric vehicle load, they're going to be able to shift it all into off-peak hours, which means that their on-peak, their daily load cycle is not going to increase dramatically during their peaking issues around 7 o'clock because of electric heat. They're going to fill in their nighttime with electric vehicles. So BC is going to shift from having a very big day-nighttime cycle to a much flatter cycle. And if we do it right, we'll do the same thing, which has implications for what kind of generation you want to build. So possible synergies with BC. We could sell our wind energy to them to meet their future energy deficiencies. Or BC could store our wind and return it firm, converting 5,000 megawatts of wind into 2,000 megawatts of firm generation. And if we upgraded the tie capacity to and the N-1 reliability to the tie capacity, both Alberta and BC would benefit from a reduction in reserve requirements to maintain the same LOLE, which, if you don't know, that's loss of load expected, or expected loss of load, some people call it. Another opportunity for Alberta here is which is why the BC tie was built originally in 85, I think it was finished. You could sell during off-peak hours. It's not going to be as much as it used to be, but you could sell off-peak baseload nuclear to BC for them to use to meet their future energy deficiency. So, given those synergies, what are the economics? So I looked at the cheapest way, in my opinion, the cheapest way to increase the tie capacity between BC and Alberta would be to extend the Wattle HVDC line from the Keephills plant, extend it to the Williston plant in British Columbia, which is basically due west of Keephills. So basically, you follow the Bickerdike line, you keep going, go a little north, and you're at the midpoint onto BC's 500 kV system. And to do that, an order of magnitude cost for that would be about $2.1 billion, which works out to about $1 million a megawatt. So the cost for wind exports, if they were charged for that transmission, would be about $37 a megawatt hour. So given today's generating technology, which is why it's never been done, is it's not economical. The line would cost more than it would be for them to firm up their wind with the gas-fired generation because of the low capital cost today of gas-fired generation. But in the future, at $37 a megawatt hour, and our wind is depreciating, with a depreciated wind value, it would be cost competitive with new coast wind in BC. And so BC would be motivated to buy our wind rather than build their own wind plants. And then to get 2,000 megawatts of firm N-1 capacity out of BC would cost us about $15 a megawatt hour to buy 2,000, which is very reasonable. And again, it's very attractive up to the point when BC runs out of their capacity surplus. Because once you run out of the surplus, now you're going to have to start paying money to actually get the capacity rather than just using what you already have. The reduction in reserve requirements, and again, this is based on the assumption that Alberta went nuclear, it would roughly reduce on both sides of the border BC's capacity surplus, so they don't care. But in our case, if we put in a nuclear fleet, it would basically save us 1 unit, and possibly 2. But two nuclear units is over $1 billion. So when you're paying $2 billion for the line, but you save $1 billion on your reserve requirement, it makes the line even more attractive. So but doing round trip firming, I think the transmission cost would be too high unless you discounted the line against your reserve. The most likely highest benefit would be to simply sell the wind power to BC. And again, the other alternative I talked about is you want to run your nukes flat, the same as we used to run the coal plants. And it's an advantage, but one of the big advantages of nuclear plants is they have a really high variability and they have a really low forced outage rate. And those are advantages for system cost as a whole because you need lower levels of reserves, so you need less plants. But what it means is that especially in today's gas-fired market, the spring and fall lows of your system demand, your seasonal system demand, those can be filled up with the maintenance on the units. And so what you actually end up with, even the load cycles and drops in the spring and the fall, when you throw in your maintenance on your plants, your capacity requirement becomes very flat. It's completely flat throughout the year. And then if we do electric vehicles right, our nighttime peaks are going to be mostly filled in with vehicle charging. So we're going to end up with a very flat load profile. But if you go nuclear, they don't have very many planned outages. Their reliability, their availability is so high that you don't need all those lows to do the maintenance. And so if we went nuclear, we would be back to having surplus energy in the spring and the fall if we went nuclear, which again, we could sell to BC at the cost of $37 a megawatt hour for the transmission. And so, again, that would be very competitive with anything else that BC could purchase. So the last slide I did, and you're probably pretty well figured out what I'm going to say on this one. That's okay. So what would I do? If I were in charge, what would I do? First thing I think the government has to do is you've got to stop the wind and solar subsidization. And the NDP government did try to do this, and I don't know who gave them their advice. I thought the one thing they did I thought was really clever. The other thing I thought was really bad. What they did was it was really clever we put billions of dollars into the transmission system. And so what the NDP did is they said, no more wind development unless you use the transmission that we've already built. And we're going to put it out for auction. And what they did is by putting it out for auction, basically you're getting back some of your investment in the transmission because you're making them compete. And the lowest price guys are going to go in there, and any surplus profit made on the wind goes to the government, basically holding the generating plants. And that would help offset the transmission. So I thought that was a really clever way to try to get some of our money back. The other thing that they did, which it gets back to firming, is they tried to introduce a capacity market. And Alberta is almost, as far as I know, Alberta is the only energy-only market in the world. And there's a really good reason for that, is because energy-only markets distort cost causation. Because the guys, especially when you add more and more renewables. Now, I know why they did it. When the industry was originally created, it would have worked okay. But as you add more and more renewables into the mix, it really distorts the cost of the thermal plant relative to the wind and solar. And it causes market distortion. And that's why the free transmission and the fact that the wind doesn't have to firm, that's why we have this gold rush of wind and solar plants in Alberta. It's not because we've got the most economic jurisdiction, most economic physical location for wind and solar. It's because we have a jurisdiction which subsidizes it so heavily by not requiring them to pay for transmission and not requiring them to pay for firming. So, KISC, keep it simple. I'm not a, they made it way too complicated. So capacity market, I looked at it and thought, this is doomed to failure. There'd be so many people fighting against it because so many people benefit or lose, and it will tick forever. The simple fix to this is don't touch the market design. Just put a transmission tariff in place, charge the solar and charge the wind. And what I'd put into the wind is, I don't think you can ding them for 100% of the transmission. The transmission is, the amount of money we spend on transmission is way more than it's actually required to serve their needs. And it's not fair to ding them for our mistakes. But you could ding them for, say, 50% of the sunk wires cost and 100% for a natural gas combined cycle firming cost. And what that would be is charge the wind guy $33 a megawatt hour, and for solar it'd be $53 a megawatt hour. Now, whether or not that would be enough to reduce the people entering the market, probably not. But at least now they're paying their own way. That you remove the subsidies, and it may cause some people to drop out and reassess kind of the risk. But the other thing I do on this is tell them, when we move to a net zero grid, here's the cost of these technologies, huge capital costs. Your firming cost is going to go up by another $100. So if we go to a net zero grid in 2035, you're going to be paying $133 a megawatt hour for firming your wind, and solar is going to be $150 a megawatt hour. And I think that would really make stop and think. And it's not like, I'm not suggesting that you be punitive. All I'm saying is tell them like it is, but start making them pay the costs of operating in a thermal, basically a province that has no hydro. Wrong slide. The second thing I do, and I'm sure the government wouldn't do this, I'd set up a BC tie crown utility. So I put the tie into a separate utility. I'd kick in $500 million, $500 million to get this utility going. And I'd give them all the rights to buy, sell, and market the transfer capability on BC tie, and tell them to go and make it as profitable as they can. And then at the same time, immediately start developing a 3,000 megawatt increase on the tie capacity, and then go and do a deal with BC. And what I would shoot for is try to get, okay, we set up this crown, let's put your tie capacity and facilities into this jointly owned utility, and we'll do a 50-50 split. And then I'd go and contract for 10 years worth of wind, and have BC contribute their capacity, which they already have. It doesn't cost them anything to firm it up. And that would cover your tie probably for at least the first 10 years cost of operating the tie. And the reason I say to put it into a crown, put the BC tie into a regulated utility crown corporation is politically, I think that would play a lot better in BC. I think to some extent, there's always this friction, I would call it friction between, BC says, okay, our regulated utility is, and it has very low cost, is the way to go. We want nothing to do with your market stuff. And Alberta's saying, oh, we're capitalism, free enterprise, market. We don't want anything to do with regulated utility. So I think if you created a regulated utility and then hit them with that, it would kind of turn the tables on them a bit. And I think that would help you with negotiation. I think if the BC knew that, we're all in this together, all of the profits that are made by this company end up going back to the people of BC and Alberta, I think that would play much better politically in BC. That's why I would recommend that. And the last one, which you probably know, is create a crown corporation for nuclear and jump into it with both feet. So I'd put $3 billion into this company as a startup. It's not going to be cheap, but give them make it a crown corporation so that the money goes to the corporation and a change of government can't suddenly shut the whole thing down. And give it a board of governors. And then these guys can work on all of the things that Alberta needs to do if we want to do a nuclear industry, which is legislation, regulation, the approvals process, acquisition and permit approval for sites for nuclear. And the other thing I would do would be to commit fully to the Stream 2 advanced generation. It's risky. The Stream 2 is risky. So there's 3 streams, but the 2 streams, if you're not familiar with the small modular reactors, is that Stream 1 is basically a small version of conventional technology. It's a boiled water reactor, and that's what they're putting in at Pickering, and now they're going to put in 3 more. So they're going to do 4 at Pickering, and Saskatchewan's putting in 3. So it's lower risk because it's existing technology. It's just basically making it smaller and putting some bells and whistles on to make it more intrinsically safe. But it still has the warts of a boiled water reactor in that you can still have a meltdown and you can still have, it's operating under high pressure. And so you can have what the public fears is a Chernobyl event. It's going to rupture and spew radioactive steam and gas across Edmonton. The Stream 2 are molten salt reactors, 2 molten salt reactors designed. And the beauty of the molten salt reactor is that there are no catastrophic events. Like if the reactor shuts down, it just sits there basically. It doesn't operate under pressure. It operates at atmospheric pressure. You're circulating high temperature molten salt at 600 degrees Celsius or whatever within the plant site, but you can't spill, you can't have a meltdown, and you can't have a high pressure release of gas, etc. And so I think that would be that's and the reason the government I think is pursuing molten salt is for the same reason, which is it's an easy sell to the public. If you go to the public and say it's in an underground vault and what happens? Like if we lose control of it, we turn it off and it sits there and it gets hot and it reaches a stable temperature and it sits there. It's not under pressure. It can't release gas. The core can't melt. It's intrinsically safe. That's the big appeal of it. And I think they're more expensive, but I think it would be way easier to get them permitted and accepted by the public compared to conventional reactors, especially given the locations of the coal plants, which is where we'd want to put them. Most of it is you're going to want to put around Wadman, just west of Edmonton. So it's got to be a very safe plant. So I think it's got to be the 4th generation. But to advance and fast track the development of the 4th generations, Alberta would have to kick in a lot of money and be really serious about their intent to install the nuclear. I put 2020. It's nice. 2040. But I think there's huge opportunities for Alberta as well. If we took on a much bigger role in the 4th stream, much of the technology development, research development, prototyping, and even construction of prototypes can be done for all of the balance of plant. The secondary heat loop, which is a molten salt loop that runs through a steam generator, all of the balance of plant, all of that development could be done in Alberta. And then what you're doing is you're we'd be designing and building the buildings, the infrastructure, the balance of plant facilities. We could do the steam generator, the molten salt, and then there's a factory that assembles the reactor module. You plunk it in, and it loads in like a cartridge. This design is basically the concept. So anyway, that's my that's what I would do. I don't think I'm going to convince the government to do it. But that's it. I'm over time. Part of that I blame on our technical fumbling. So I guess we'll open it to questions then.
You talked about electrical vehicles. I guess, what about heating the homes that they use in the gas heating homes? Is that sort of project carbon or not?
The question is with regards to the switch to electrical for heating homes. I don't know what to think of that. Quite frankly, heat pumps work great in British Columbia and in Southern Ontario. They suck on the prairies, but the Liberals don't have a lot of votes in the prairies anyway.
Full cost for power.
So, well, I guess where I'm going with this is I think it'll be a long time before heat pumps would. There has to be technology advancements before we could switch to heat pumps. I don't see a switch from natural gas heating in the near future myself. I know that it's not that goes against meeting our climate change goals, etc. But just pragmatically, the cost to the only heat pumps that'll work in the prairies, you've got to do groundwater heat pumps, and they're so very expensive. I just can't see the prairie provinces switching to heat pumps. So in the load forecast, and I'm not sure, I looked at the ISO forecast, I don't think there's heat pump load in there, and I agree with that. Sure.
The first one you mentioned in the presentation, 95% capture. How you arrived to 95% capture, given the fact that the boundary date is something that will achieve more than 80%, and make sure that it has been closed on a commercial scale. Also that's something that will achieve more than 80%. So is based on the studies that like against all MHIs and past all the world are publishing. The reason why I'm asking is we actually met with the government. We're trying to tell the government that see our regulations we're proposing, they're not based on like a commercial value, right? That's kind of like when they based on Shepherd.
Yeah.
People might just invest in technology. So if you talk about that, the other one was could you wait?
Okay, so So the first question is around the integrated combined cycle carbon capture and storage, 95%. Where does that come from? So I should have said all of this cost data is done by is based on the NREL database. I'm not sure if you're familiar with it, which is natural, renewable, electrical, whatever that that it used to be under the U.S. Department of Energy, and that's the equivalent. But they've always done lots of fantastic stuff done by the U.S. Department of Energy. What they've always done for many, many years is they gather statistics on every plant operating in the United States. They've been doing this ever since I've been doing this, which is back to 85. Well, no, probably not 85, probably be 2000. Anyway, at least 20 years. But the 95% plant comes from one of their future predicted. It's never been built. It's based on a design concept, and they think that they can get 95% with natural gas, and then they cost the plant out, and then it goes into their modeling of future technology choices. That's where the 95% comes from. But you're right, nobody's built one of these, and whether or not you can actually. And the other part of the question is, I think what you're hinting at is that there's huge cost increases in these plants. If you move 85% is kind of the economic cutoff that people use, but even getting to 85% is a big step up from 75%, for example. 95% versus 85%, the question is this going to cause a huge increase in the plant? And it potentially could. I think more likely, though, is 95% capture, maybe optimistic. But, based on what's currently been achieved with carbon capture and storage, I think it's probably optimistic. But they believe that the technology will evolve to the point. This is 2035. So by 2035, the U.S., they believe that they can do it.
So I have just one more question.
Sure.
Maybe can we expand or clarify when you say like low quality solar? Does it mean low quality solar versus that?
Yeah. Okay. How do I turn this off now?
Just for example, if you compare to
You go to leave.
Yes.
Oh, there.
Germany,
And it'll ask you leave meeting and you say, you just.
it doesn't really depend on how much light you're gonna get in terms of intensity, but in terms of how much light you're gonna get during the day. And we have 320 days of solar in Alberta. So as you can see, like a traverse solar project with 30% capacity factor, with a bit of an overbuild with the tracking system. If you just say like what does it mean like when you say like low quality solar? Because we have fairly good conditions if you look at like energy we get, the cooling effect we get, so I just need to clarify a little bit.
Yeah, like when I said, the question is what did I mean when I said we had low quality solar resources? And the answer is I'm saying relative to the southern U.S. deserts and the deserts of India, for example, and just on solar, you can optimize it for the local conditions. The question really is that pointed that out. Like you can add, basically what you can do is you can add more area. You can put in way more panels and save some money on your converters, and you can pick up more light that way and get your capacity factor as per measured at the capability of the inverter up. But you have to be aware of the fact when you're adding more panels, taking up more real estate, you're putting in a more expensive solar plant. And so, it's nothing comes for free. You can save some costs on the inverters. But the other problem with solar, which is kind of what I alluded to, is when you look at the total cost structure, your capacity factor is still lower than wind, and so your firming cost is going to be higher, or your transmission cost is going to be much higher. You do get, and it's frustrating, there is some synergy between wind and solar. Like if you look at the correlation between the two, they don't typically occur at the same time, but unfortunately sometimes they do. And so again, it gets back to, you've got to build, it gets back to our rules. Like if you're building a system, the ISO is required to have guarantee no congestion, which means you have to build the system for the worst hour of the entire year. And it's not a great way, it's not cost effective, but that's the way the regulations are written today. And so that's why solar's transmission costs, I put it in so high, is because the utilization of the transmission is lower, which means it's going to cost them more for that capacity.
Sure. I've got a question from Zoom online, and it's from Leo Clayman. And his question is, recent Forbes article entitled "Central Banks Are Waging War on Renewables." The article notes that the increase in interest rates has resulted in a high discount rate that diminishes the value of renewable assets. It notes renewable companies are seeing their stocks in 52-week lows. Could you comment on that? Thank you.
Yeah, it's a good point. Just as an aside, I was going to say and I can't remember, all the economics that I presented today are based on a common financial structure. That's the way the modeling's done by the guys in the US. And I can't remember what the weighted average cost of capital is, but it's pretty low. So it's a good point. The equity return that they assume is around 12%, but the debt costs included in all of these costs is quite low. And once you start having rising interest rates, when you have, again, going back to, you're switching to assets from assets that had a low capital cost, you go back to the combined cycle graph that I showed originally, you've got a high variable cost and low capital cost. Rising interest rates aren't going to impact the cost of plant. Again, you go to these, you move to a net zero grid where with sequestering and gas turbines or an integrated, sequestering plant, it's almost all capital. You've got not only do you have to do the capture is almost all capital. And I could show you a breakdown. Actually, I do a breakdown on that too. But it's not just the expensive generating plant. The capture plant is all capital. The pipeline infrastructure is almost all capital, and the compression and drying at the front end is all capital, and the injection site is almost all capital. So your entire infrastructure is a fixed cost that you pay all up front. And so it's a really good point, is as borrowing costs rise to what I would say would be more normal, the costs of generation is going to go even higher than what I presented here, because they are based on a low weighted average cost of capital relative to what's probably going to occur in the future.
For a layperson like me, you had some solutions in regards to the government's requirement for net zero emissions by 2035. And if I could interpret it correctly, there were some solutions that you gave, and one of them was nuclear in terms of forming a crown corporation.
Yeah, that's right.
And my question is, if a crown corporation formed, right, is there opposition to having a nuclear plant in Alberta? I suppose there's public opinion on that, but would that be one of the solutions? You alluded to that. I might be mistaken.
I'm not sure. Are you saying like would a crown corporation reduce public opposition to nuclear? Is that what you?
No, with the crown corporation in Alberta result in us attaining net zero emissions by 2035, 2040. In developing or building a nuclear plant.
So the question is if we did a crown corporation and aggressively pursued nuclear, could we make 2035? Theoretically, it's possible. Theoretically, you can do anything. I always like to refer to C.D. Howe, who was a great engineer, and at the start of the Second World War, Canada had virtually no large industry and no weapons industry. And Mackenzie King asked him to take over war manufacturing. And so what C.D. Howe did is he said to Mackenzie King, give me money with no bureaucrats attached, and keep Quebec off my back. And let me pick my own engineering team and run. And he set up a bunch of crown corporations. He really invented supply chain management, and it was amazing. I think at one point I think there was 12 corporations. I think he went and recruited about 20 engineers all across Canada to run this thing. But within a year, they were producing Lancaster bombers, and they supplied like over 1,000, I think, 1,600. Bombers towards the war effort, as well as other manufacturing, and the whole thing was done within a matter of a year. So, I mean, if you can take a forestry farming nation and assemble the entire every little tiny plant in the entire country, and within a year create a modern weapons industry, I think if you have the motivation, we could definitely do it. But the question is
you must have had
Lord Beaver broke as a pen pal because that's essentially what he said to Churchill when he was put in charge of the production of aircraft.
Is AESO a private corporation?
The question is AESO a Crown Corporation? No, it's not. It's what's it called? I think it's considered an agency. It's kind of run like a corporation, but it's not really. You know, it's mostly a way. In my opinion, it's like a number of these agencies that the government sets up. It's mostly so that the government has someone to blame for anything that goes wrong. But it's not a Crown Corporation. Part of that, I think, is the ISO doesn't really retain assets. They're supposed to be an independent system operator. So really, they only should have operational expenses.
Trevor, I've got one more question online, and maybe we'll take one final question here from people if they do have one, just because we are over time now. Angus asks, does Alberta really have no hydro opportunity or pump storage potential? Or is it just that the economics are against it? So if you address that.
So the question is does Alberta really have no hydro potential or pump storage potential? And I think the answer there is we don't have any material hydro. You know, I mean, we have hydro, but it's very small, especially in terms of energy. Much of it was built to provide AGC, you know, fast control to balance the area control air and not produce large amounts of energy. And for pump storage, now I'm going to have to go from memory. I actually have a slide for this if I could find it. Pump storage, the economic sweet spot for pump storage is, I think, between 600 meters of head and 800 meters of head. And the highest head plant in all of Alberta is Spray, which is 220. Most of them are under 60. So we're not even close. And if you just look around, and years ago we looked into this, even trying to find locations, you need a large reservoir with a 800-meter elevation separation between the upper reservoir and the lower reservoir to do pump storage. There's nowhere in Alberta that's like that. So we really don't have any economical opportunities for pump storage. And as far and the hydro goes, the only hydro development on again, off again, I think I worked on this 3 times over my career, is the Slave River hydro development. And the last go around, they cut it down to almost a run of a river. It, you know, very low dams because of the environmental impacts. The original design, which I think was done in the 60s, something like that, by Montreal Engineering, I think. But anyway, the original design was big dams. And you would have had some seasonal storage in that kind of, but the amount of environmental damage was so huge that even, I think the first time I looked at it, helped do an economic model for TransAlta was in the late 80s. We looked at it, and even at that point, they'd cut it down to very small dams, which leaves you basically at the run-of-river. So it becomes not an intermittent resource, but it's seasonally intermittent. It's basically an energy source, not capacity.
Also, just wondering if you were familiar with Quebec used to study those systems. They come up with very different results from what people they claim that solar and wind will test the majority of the solar system would be less costly.
So the question is PEMDA. PEMDA is all sorts of PEMDA's recent study saying that we could do it all with solar and wind. No, I haven't looked at their study. I would suspect that it's all being driven by not looking at total cost. Going back to what I said before, is you've got to look at the total cost, including the transmission costs as well as the cost of firm. And the big question I would have for that is, if we can do it all with solar and wind, how are you going to firm that solar and wind? Where are you going to how are you going to provide the temporary storage, and how are you going to deal with the ramp rates required, and not just the hour by hour ramp rates, but the minute by minute, the large fluctuations you can get minute by minute. As you add more and more renewables, it's just going to become a nightmare, I think, for the system operator. And when you have hydro, or if you tied in tight to hydro, like you look, for example, in Europe, Germany, where they have large amounts of intertie capacity, and they have access to large amounts of hydro, the wind works a lot better. But we don't have it. We can get a bit by tying into BC, but there's limitations to how much they can firm up as well.
I think that's answered most of our questions. A very informative talk. I only wish our betters, but the people making the decisions understood all these issues.
Yeah, and that's the big problem.
With degrees in political science and media broadcasting, it doesn't really cope. Anyway, we'd like to thank you on behalf of our group. We give you a certificate, which we make a donation to a charity that does Operation Eyesight. And so developing we do an operation, and we give money to them on behalf. And thank you very much for a very informed decision. It's amazing. Thank you very much.
Thank you.
I think